Next, a positive or negative vector. Before it, we have seen more vectors. For example, equal vector, antiparallel, parallel, polar. All this we have seen in the previous lecture. In this lecture, we are just continuing with the negative or opposite. Negative or opposite. Here we are not going to take two vectors. No. Look, this is one. This is one. A vector. My question is, what will be negative of a vector? Just your work is to convert this in opposite direction. How? Like this. Magnitude should be same, but direction will be opposite. And now, name of this vector will be negative a vector. Negative a vector. Since we have just converted it into opposite direction, that's what negative gets. So remember, if a negative is coming with any vector, so negative is a performing for a direction, opposite direction. Clear? Vector is always positive number. Always positive. Clear? So you can write like this: A is equal to minus a vector. A vector is equal to minus a vector. Magnitude is set, just direction has changed. Direction has changed. Clear? So definition for it would be what? We can change. So according to PPT, vectors which have the same magnitude but opposite direction are called opposite vectors. Yeah, you can see magnitude is same. For example, magnitude for a vector is 4.4 centimeter. So magnitude for negative vector will be same, 4.4 centimeter. This is what is the definition of a negative vector. Clear? What is it? Now, in a note. If you multiply a vector by real positive number, what? For example, this is a vector. This is a vector whose magnitude is 3 centimeters. That's direction. You can see direction. So magnitude is 3 centimeter. Note is saying, if you multiply this a vector by any real number, what will happen? It will increase. Our length will increase, but direction will be same. Yeah, direction will be same. Just length will increase. For example, we are going to multiply this a vector by 2. What will happen? So here 2 is a positive number, okay? Positive real number. When you will multiply this by 2, this will be double. Because we are multiplying it by 2. If you multiply this by 3, what will happen? This will be 3 times. This will be 3 times. So it will become like this. This one and this one. So now magnitude is 6 centimeter. So this will become 2a. A vector will become 2a. Okay, 2a means just we multiply this a vector by 2. It is meaning of a 2a. Clear? Are you observing that direction is not changing? When we increased, or when we multiply the same vector by any real number, then here you observe that direction didn't change. It happens. What if we multiply any vector by negative real number? Then what will happen? Next point for in note. If we multiply a vector by real negative number, then what will happen? Direction will change. direction will change, but magnitude will increase. Magnitude will increase. For example, now we have B vector. Clear? B vector. This is a 2 centimeter. This is a magnitude, whose magnitude is a 2 centimeter. Direction is like this. Question is saying, just multiply this B vector by minus 3 number. What will happen? You will see that minus is coming. It means it is telling you that just convert B vector in opposite direction. Who is saying? Negative is saying. Okay. So just direction will be in this direction, in backward. So one part, this second, third. Krishna was saying just multiply this by 3, by negative 3. Now you can say minus 3 B vector. Am I correct? 3 is for multiplication. Negative is for direction. B is a vector. Just we multiply this 3 by this 2 centimeter, and minus is for negative direction. Clear? Here we are saying that just magnitude is increasing. Can magnitude decrease? Can magnitude decrease? So how will magnitude decrease? How will magnitude decrease? You know, if we multiply any number by any number, of course number will decrease, will increase. Reason is we are multiplying. Opposite of multiplication is what? Division. If you divide any number by any number, what will happen? Number will decrease. For example, we have C vector. Clear? Whose magnitude is 4 centimeter. Question is saying, just you divide this 4 or C vector by 2. So let's say now what will happen? If you divide this 4 by 2, your magnitude will be 2 centimeter. It is saying just make a line segment whose magnitude should be 2 centimeter. Clear? 2 centimeter. Okay. So if you draw another for this, so what will happen? Magnitude will be same. Just length will decrease by 2 centimeter. It happened how? It happened when we divided this 4 by 2. Then it happened. Then 2 number came. Okay. Now here you can write it like this. C by 2. C vector by 2. Clear? Okay. If you are dividing any vector by negative number, what will happen? Direction will change. That's it. And magnitude will decrease. Why? Division. Why? Dividing. Why? We are dividing. Okay. Till here we are clear. Okay, next. If we multiply a vector by real negative number, then its direction changes by 180 degree. Here you can see theta is 0. Here you can see theta is 180 degree, which is very basic. This was very basic. Okay. Next point. If we multiply a vector by 0, then magnitude will become 0. Direction will be same, but magnitude will become 0. And this type of vector is known as null vector, so 0 vector, where magnitude is 0. If a magnitude is 0, a vector whose magnitude is 0, then you can say this is a null vector or 0 vector. Clear? It becomes null vector. Now next type of vector which we have, it was about negative of any vector, which is a type of vector. Now we are moving to the next type of vector which is a coplanar. Coplanar. Okay, coplanar. I think it is also not difficult. Coplanar. Coplanar vectors. Co means compound. Co means CO. Co means compound. Two or more things. Since we have vectors, so it will become two or more vectors. Two or more vectors. Planar means plane. There are a lot of vectors, but but those vectors are on a single plane. Are on single this like this board. This board is an example of a plane. On this board you can see there are how much vectors? This 1 2 3 4 5 6 7 8. There are 8 vectors. So yes, it is a definition of a coplanar. Means there are a lot of vectors who are present on a single plane. Don't take two axes, don't take three axes, otherwise it will not be definition for coplanar. Okay, you will have to take only one axis. Two axes means yes, you can take two axes. This y axis, not take three axes. So on a single plane, if there are a lot of vectors, this is a coplanar vectors. Clear? Yeah, direction can be any direction. Magnitude can be any number. Magnitude can be any number. Do you know collinear? Collinear. Collinear vectors. It says that yeah, co means compound, two or more. Compound, two or more. But linear means here we saw planar means plane. Here linear means line, a straight line. So if there are two or more vectors, but those vectors are along a single line, along a straight line. For example, this is a line. If on this line there are a lot of vectors, this will be our collinear, where vectors are just along a single line. Along a single line. Now next we have null or zero vector. Null or zero vector. Remember, magnitude, if a magnitude, if there is a vector whose magnitude is 0, then that vector will be our null vector. So vector with 0 magnitude is known as a null vector. Its direction is not specified because magnitude is 0. So direction, how will you get a direction? Example, sum of two vectors is always a vector. For example, this minus 5 plus 5 will give you 0. Direction, that is a north direction. What are your, this is our null vector. Null vector, or you can say positive a vector and negative a vector. What will happen? Result would be 0. Result would be 0. Clear? Here 0, you can represent this in the vector form like this: 0 and arrow. Arrow is for direction, but magnitude is 0. Magnitude is 0. Now next we have unit vector. That means next we have unit vector. unit, unit. Unit means one. Okay, always remember unit means one. यूनिट का मतलब ही वन होता है, और यहाँ वेक्टर है. वेक्टर इज अ टाइप ऑफ दिस यूनिट. वेक्टर इज अ टाइप ऑफ वेक्टर. सो जैसा कि मैंने कहा, यूनिट फ्रॉम वर्ड वी कैन डिफाइन एनी any type of something. For example, this is a type of vector. Here from word we are getting clarity. Unit means one, means magnitude is one, and direction is anything. Okay, direction is anything. So magnitude is one. Any vector who has magnitude one, we will say this vector is a unit vector whose magnitude is one. Okay. So magnitude is one, direction is a something, direction is not something. There is a direction. Okay. Unit means one. It will help a lot of time. Even in the chapter of motion in two dimension, motion in one dimension, not in one dimension, but motion in two dimension. This will help a lot of times, Okay, that's why we need to emphasize, we need to emphasize on this unit vector. So I will explore it in detail so that you can get clarity. Okay, you can get clarity. चूंकि हम लोग डेफिनेशन देख चुके हैं फॉर यूनिट वेक्टर, इट सेज दैट आई हैव magnitude one and a direction. या एक मेन पॉइंट है इसमें कि इसको यूज किया जाता है स्पेशली फॉर डायरेक्शन. या इसको यूज किया जाता है डायरेक्शन के लिए, क्योंकि ऑलवेज फॉर द ऑल टाइम magnitude will be one. For the all time magnitude will be one. इसका मेन वर्क जो है वो डायरेक्शन के लिए है. डायरेक्शन के लिए. Yes. Whenever you will see use of unit vector, you will observe direction, importance of a direction. Clear? Importance of a direction. Magnitude is a one, brother. Magnitude is a one. So PPT is the same. A vector with unit one magnitude. Again and again I was saying magnitude is one. Magnitude is one. So is called unit vector. Okay, a unit vector is represented by. Here symbol for this will be different. During this lecture we were using a symbol arrow, but right now for unit vector symbol is like this. Symbol is a magnitude, but symbol for unit is this cap. Okay, A cap, B cap, X cap. जब भी ऐसा कहा जाए A cap, X cap, it means we are saying this is unit vector. X cap is unit vector whose magnitude is 1. Okay, so this is how we represent any unit vector. Okay. And this is how we represent any vector. Okay. This is a vector. Can you write a vector like this? A cap, not a cap. First of all, magnitude. So mode of a vector. This is magnitude and direction. Where is the direction? So for direction, we use this A cap. Multiply this, multiply this. What are those? You are saying that magnitude multiple direction will give us a vector. That is what you are saying. That is what we are understanding over here. Okay. ऐसा this A vector that I wrote. Why did I write like this? There is a reason. Reason. Reason is first point always remember. It will be used for a special direction. A special direction. Okay. For always direction. From this equation, we can find direction of any vector, direction of any unknown vector from this equation. And you know how did it come? You know that this is a definition of any vector. A vector, it means it has magnitude, it has a direction. Just we multiply, and after multiplying we get vector. From this equation, if equation is saying find the direction of any unknown vector, then we will use upcoming equation. So a cap will become a vector upon mod of a vector. Mod of a vector. Clear? Mod of a vector. This is also, you can say it is a formula. This is formula. Yeah, it is formula. We will use this a lot of times. A lot of times. A cap is equal to vector upon magnitude of a vector. Vector upon magnitude of a vector. Okay. It can be this equation can be written as a vector is equal to, चूंकि हमने mode को यूज किया, since we used this mode, then this mode of a vector, this can be written as a, who is saying that yeah, I am only man. So this mode of a vector is equal to a. Mode of a vector is equal to a. Okay, a. Okay. Three things you see over here. Three things. First, vector is equal to mode of any vector multiplied by direction provides a vector, and from this we got cap, a cap. We know that हमने जाना कि this mode of any vector can be equal to a vector. Clear? So note में है, a unit vector is used to specify the direction of a vector. Yeah, I have told a lot of times. Multiple times I have told this statement. A unit vector is used for a specific direction. Okay. Now let's explore more about it. Three standard units vector. Three axes we are taking. Three axes. This one axis, which is a y. This another, which is a x, and this third, which is a z. There is a twist. Twist is we did not write it in the form of a vector. How to write all this y-axis, x-axis, z-axis in the form of a vector, in the vector form? That is, x is always replaced by I cap. X is always replaced by I cap. Okay. What about y? Remember, y will be replaced by z cap. Okay, no problem. Third, which is last, will be replaced by k cap. Okay. So I, j, k cap, all these are in the vector form. Here remember, these two vectors are this two vectors is forming a angle which is a 90 degree. Here will be also 90 degree. Here this is Z. Z is outward. It can be inward, outward. Okay, that's why you will see that between I cap and K cap angle is 90 degree. Okay. So remember this Z is outward. It can be outward or inward. That's why angle between two vectors, angle between x and z, we will get 90 degree. We will get 90 degree. Okay. So these are three standard units. These are three standard units. So x, y, z. This is used for coordinates. For coordinates. When we are saying x, y, z, it means we are providing coordinates. It is only coordinates, not having direction. Friend, there are three unit vectors. Here, when you will use I cap, j cap, k cap, here you are providing units with the direction. Units with the direction. For example, 5 I cap. Here 5 means 5 unit, and I cap means along x axis, along I cap. Here object covered 5 I cap. Here you will interact with this number by you will say yes 5. It covered 5 from the origin. It covered 5 along I cap, 5 centimeter along I cap. That is how we will interact, okay, with any unit vector. Here. So this I cap is saying this 192 and then I cap. This 192 J cap. This 192 K cap. Magnitude is you know one is hidden. One is hidden. As we see that addition is hidden with any number. Same. One is hidden with any number. Okay? Remember whether I is perpendicular to J cap. J is also perpendicular to K cap. Perpendicular means between them angle is a 90 degree. Okay? Between them angle is a 90 degree. This is what is the meaning of a perpendicular. Perpendicular. Okay, this is not enough. It's not enough, okay? Just we saw three standard units in the form of a vector form. Just we replaced x, y, z coordinate. Remember x, y, z are coordinates, and I cap, j cap, k cap, all these are in unit vectors. Okay. Why do we use this unit vectors? You know. You know. Okay. Example we have. Example. Three vectors A, B, C are shown in the figure. Find angle between them. Find angle between. So let's see angle figure. So question is saying find the angle between A vector and B vector. Clear? B vector and C vector. Clear? A vector and C vector. Okay. Okay. Clear. 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 Figure for each question which we have first. Look at over here. Look at over here. There are three figures. Question is asking angle between them. Look, here x is not vector here. This x is not vector over here. It is a coordinate. Okay, which is a fixed. Which is fixed. So angle between them. Angle between A and B. This A vector and this B vector. It can confuse you, but carefully try to answer it. Carefully. Shall I erase this part? I think so. Yes, yes. I should erase this part. Look, this is the x coordinate, okay? Don't consider x coordinate as a vector. Okay. Main question is finding angle between a vector and a b vector. So a vector is over here. A vector is like this. Here angle it is formed 30 degree a vector. So let's draw b vector as well with this x coordinate. So b vector is like this, and angle from the x coordinate till the b vector is 30 again, 30 degree. 30 degree. This is a b vector. Now, are you getting clarity? Can you tell angle between them? Now it is easy. This is easy. Look, answer would be 30 plus 60. 30 60. Main thing was, it was confusing you. Right now, just we shifted this b vector with this initial figure. Over here. And now we can see, we can ignore this x because question is asking angle between a and b vector, not angle between a vector and x coordinates. Okay, that's all. So answer for this would be 60 degree. 60 degree. Finally, you have answered. Now B. Second question is angle between B and C vector. Angle between B and C vector. So first of all, take B vector. B vector. Got it. B vector. This is our B vector. It is making 30 degree angle with the x coordinate. So it is also compulsory to take. Yeah. Don't ignore this part here. So this is 30 degree from the x coordinate. 30 degree from the x coordinate. Now, what about C? This C. C over here. C is over here. C is over here. Angle from the x coordinate is how much? 45. Is how much? 45 from the x coordinate. So here, if we see angle between B and C, if you want to find angle between B and C, so how to find? You know that just we will subtract this 45 minus 30. 45 minus 30, it will give you 50 degree. So 50 degree is a part of this rotation. 50 degree is a part of this rotation. Okay. No problem. This is our answer. So finally, second answer. Finally, second answer came out as a 50 degree. यहाँ हम लोग देख रहे हैं कि किस तरह एंगल को फाइंड किया जाए बिटवीन टू वेक्टर्स. किस तरह? One thing more which we need to focus on connection of two vectors. जैसे कि two vectors A and B vectors both are connected tail to tail. Am I correct? Yeah. Also in this case, the C vector, V vector and X coordinate, all these three are connected head to head. This is also correct, right? Now, C. C. C is asking A vector and C vector. So A is over here. This is A 30 degree. A vector, got it. And C, this is C, which is making 45 degree from the x coordinate. 45 degree from the x coordinate. So this rotation part that is asking is how much? It is how much? Angle between them is a 75 degree. Answer would be 25 degree. 25 degree. This is the angle. 25 degree is the angle between A vector and C vector. And both are connected to head to tail to tail. Both are connected tail to tail. Okay. Okay. This is also done. This is also done. Shall we move towards the part? Next part. Next is also question. Okay, next is also question. I will draw figure and direct you have to answer. Directly you have to answer. Look at this is our next question. If you are beginner for this, you can get confused. But carefully try to analyze it. Carefully try to get clarity. Okay, it is asking. Yeah, let me write. Let me complete this question. Angle between A and B vector. B and C vector. A and C vector. Look at over here. Just see A vector and B vector. First of all, we are solving this first. A vector and B vector. Where are these vectors? This A vector and this B vector. You can see this A vector and B vector are both connected to each other, tail to tail or head to head. Answer is yes. If you shift this over here, then what angle will you get? 120. So you can say for answer for first is how much? 120. Angle between A vector and B vector. And connection is correct. Connection is incorrect. Second question. Second question. Second question. Second question. Angle between B and C. Angle between B and C. So B vector is where? This is B vector and C vector. Here you can see. This is also connected head to tail to tail, which is correct. Connection is correct over here. So angle would be 120. 120. Okay. Now it's a time to find angle between A vector and C vector. This is A vector. C vector is this. If you shift over here, Then what will happen? Again 120. 120, 120. Is it correct? Yeah. 120 is for each question. 120 is answer for each question. Okay, each question. Now next question, let's take. Next question is like this. This is our next question, which is just figure, and let me read question. I will not write the question because it will take time. That's all. So to save time for you and for me, that's why I am not going to write. I will read. I will read too much, as much as we get clarity. So question Vijay walks towards east. Towards east, okay, towards east with a certain velocity, with this much velocity. Okay. A jeep is traveling along a road which is 30 degree, which is 30 degree west of north, west of north, 30 degree. A jeep is traveling. Jeep is going like this in this direction, west of north, west of north by angle 30 degree. Clear? While a bus is traveling in another road which is 60 degree south of west, means this west, south of west by 60 degree, south of west by 60 degree. Means this bus is going in this direction, ship is going in this direction, and Vijay is walking in east direction with some velocity, with some velocity. Clear? Till here we are crystal clear. Find the angle between velocity vector of find the angle between velocity vector of first we have Vijay and Jeep, Vijay and Jeep, and second we have Jeep and bus, third bus and Jeep, bus and Jeep. As you saw how to find angle between two vectors, same here. Jeep is a vector, bus is vector, Vijay is vector, Jeep. So angle between them we have to find. Read the question completely. Find the angle between velocity vector. Here we are going to find velocity vector of a Vijay and velocity vector of a Jeep. You know that visa is working in this direction, jeep is going in this direction by making an angle 30 degree with the north, and the bus is going in this direction by making an 60 degree angle with the west, south of west of north. Okay, so how to find first, focus on first question, visa and jeep. This is visa and jeep is in this one. So you know this is our 90 degree. This is our 90 degree. So 90 plus 30 will be 120 degree. Will be 120 degree. I think 120 degree is answer for first question. Question was asking find angle. It is not asking velocity. This is not asking velocity. Okay. So find the angle between velocity vector. So it was saying this Vijay person who was going in east direction with some velocity. Okay, no problem. But main question is to find angle, not velocity. Jeep was also traveling with some velocity. Bus was also going with some velocity. But main focus is on to main focus is to find angle between them. Okay, so angle between Vijay and Jeep. Already we have given this 30 degree, and we know that this north direction is perpendicular to east, which angle is providing which is a 90 degree. Okay, so 90 plus 30, it is a complete angle between Vijay and Jeep, and second Jeep and bus. This is Jeep and bus. 30, 60 and 90 minus 30 will be 60. So this angle is 60. Am I correct? Just add this 60, 60, 30 will be our complete angle. I think. Don't take this 30. Don't take. Reason is between Jeep and bus it is asking. So 60, 60, 120. Again, angle between Jeep and bus will be 120. Now next we have bus and Jeep. So where is bus? This bus and Jeep. Again 120. Again 120. This is our answer. That is how you will find angle between any two vectors. Okay, angle between any two vectors. Okay, next question. Let me have. This is figure for the next question, and a statement is a vector A makes an angle 30 degree. Okay, an angle 30 degree with the y-axis. Yeah, with the y-axis. Okay, in anti-clock means like this. This is going in this direction. Anti-clock means this A vector is rotating in anti-clock direction. Okay. Another vector B. This vector B makes an angle 30 degree with the x-axis. Yeah, with the x-axis, not with the y-axis. Okay, with the x-axis in clockwise direction. Direction is in this direction. Okay, like this direction. Means B vector is rotating in clockwise direction, and A vector is rotating in anti-clockwise direction. Okay, in anti-clockwise direction. So main question is to find the angle between vectors A. It is asking find the angle B. A and B. This is over here and this is over here. Now that angle between X and Y is fixed, that is 90 degree. And now our work is to add this 30 plus 30 with 90, 90 with 30, which will be complete angle between A vector and B vector. So answer is going to be, how will you write? Just write this angle 30 plus 90 plus 30. 90, 30, 120, 120, 30, 150 angle. You can write it in another way also. 150 is the answer for this question. Clear? Clear. Next question is the component of a vector along the x. Let's say, let me erase this part. Let me erase this part. Next question is saying the component. This is y-axis and it's a x-axis. There is a one vector, a vector. Let's say a vector. It is saying the component of a vector, the component of this vector, according to this theta, this will be our a cos theta, and this another component will be a sin theta, vector a sin theta. Okay. X along the x-axis, the one component along the x-axis, and y directions are n plus 1 and 1. Try to understand. This is our n plus 1 and this is our 1. Remember, this is one component and 1 is another component, respectively. Directions. If the coordinate system is rotated, if we rotate this coordinate x and y coordinate, if we rotate this by an angle 60 degree, and initially was over here, and if we rotate by 60 degree, so this x will go over here, and between this angle will be 60 degree. That is what question is saying. Is rotated by angle 60 degree, then the component change to n and 3. Then what is happening? This n is becoming, this n plus 1 is becoming n, and this 1 is becoming 3. When we rotated coordinates x and y by an angle 60 degree, then this component became n and this one component became 3. This is what happened. Okay, then the components change to n and 3. Find the value of n. Did you understand what is question saying? Question is saying there are two axes, x and y. There is one vector, this vector. Okay, so one component of this vector is n plus 1, which is along x-axis. Clear? Another component of a vector a, which is 1, it is along y-axis. Okay. Now twist is, now you have to rotate this xy by fixing a fixed axis, this main origin, by fixing this. Okay, so now you have to rotate this coordinate system by an angle from the initial, by an angle 60 degree. In that case, what will be changes? You will see that the component is becoming n. Initially was n plus 1, and y, another component which was initially 1, but now it became 3. That is what question. It is a question. Okay. Clear? And this is asking value of n, nothing else, only value of n. So remember, we are going to solve it. Length of the vector, length, here direction will change when coordinates will be rotated, then direction will change. Yeah, it is 100% possible, but magnitude will be same. We saw concept that yes, if we rotate a coordinate system, then what will happen? Direction will change, but magnitude will be same. That is what we saw when we were discussing concept regarding vector. Okay, length of the vector does not change on rotation. So length will be same. So you can say this one component plus this one component will be equal to vector n. Am I correct? So just write under root of n plus 1 raised to power 2 plus 1. Again, this was initial components. So final component is what? N raised to power 2 and 3 raised to power 2 plus it will be n under root of n under root. Okay, so n square plus 3 square, which is a n, which is a under root, which is a n under root. Now, how did we write this equation? We wrote that under root of n plus 1 raised to power 2 plus 1 raised to power 2 is equal to this. How did we write? Answer is we can see x, y both are at 90 degree angle. Magnitude will not change itself. Magnitude will not change, but direction will change itself. We have seen this thing. So here we know that this a vector will be equal to again a vector. Both are equal. Just angle changed. So what is happening over? We know that this n plus 1 raised to power 2 plus 1 raised to power 2 is equal to this a vector. Am I correct? Now finally this became n. So now method is same. N raised to power 2 plus 3 raised to power 2 will provide our a vector, which is the resultant. Okay. That is how we understood, and then we wrote this equation, which is equal to LHS and RHS, both are equal. Now our work is to simplify this. We can observe what we will apply algebra n plus 1. After simplifying these, n square plus 1 plus 2a plus 1, n square plus 3 square, 3 3s are 9. This root will cut to each other. N square, this n square will cut to each other. 1 plus 2, 2n, 9 minus 2, n 7 by 2, 3.5 is the answer. So here value of n is equal to 3.5. This is our answer. 3.5. Okay. So main thing was when it was rotated by an angle 60 degree, then just direction has changed, but magnitude was same. So that's why we used you can say Pythagoras theorem. Okay, Pythagoras theorem. Now next question. Let me erase. Next question, which is a little bit different, but it will be based on concept that we saw, that we understood. Okay. So question is a weight is a force. So a weight which is equal to mg mg is suspended from the middle of a rope. There is a rope and mg is suspended, okay, from the rope, okay. From the middle of a rope whose ends are rigidly ends, we are saying ends whose ends are rigidly clamped at the same level. The rope is no longer horizontal. Horizontal, you are, the rope is no horizontal. This is not no longer horizontally, okay. What is the minimum tension required to completely strengthen the rope? Means when mg came downward, then what tension do we need to apply so that rope can attach weight, so that rope can balance, can take what weight, which is mg, okay. Let's draw a diagram so that we can get clarity by visualizing, by visualizing. This was our rope. This line was our rope. When we put a object at the middle of this rope, what happened? This came downward, you know. Little bit it will come downward. Reason is weight, weight, weight is coming downward. mg is a pulling downward. mg is a pulling downward. So this came to pull over here this much. Okay. So of course there will be theta and this will be theta. Okay. Object, initially object was over here, but finally object came over here. Okay. You know this will be our tension T. Tension T. If you draw this one horizontal and this another vertical, what is happening over here? This is our angle and this is our another angle, theta, which is alternative interior angles. Alternative interior angles. You know that downward will be our mg. This mg is pulling this object mg. Okay. According to this theta, this will be our what? Cos theta. Means you can write this as a T cos theta. Do you agree? Do you agree? According to this theta, T cos theta. How did this theta came? How did this theta come? So it came from here, theta. According to alternative interior angles. Yeah? Okay. If this is T cos theta, you know this T is our resultant. We are considering this T as a resultant vector. So one component is, this is one component and this is another component. Am I correct? Yeah, you are correct. So this will be our T sin theta. Similar over here. This is so resultant vector. So one component is this and this is another vector. So according to this theta, this will be our T cos theta, which is one component, and this T sin theta. Try to observe. T sin theta is common over here. So T sin theta plus T sin theta will be 2T sin theta. So over here we have 2T sin theta. 1T sin theta is for this vector and another 1T sin theta is this vector. Both are coming at this same location. Clear? Question was asking how much tension we need to apply so that object can be balanced by a rope. How much tension? So let's find. You know this 2t sin theta will be equal to mg. This t cos theta will be equal to t cos theta. Where object is in equilibrium. Where object is in equilibrium, then vertically components will be equal to each other, and horizontally components will be equal to each other. Where situation is in equilibrium. Okay. So you can write 2t sin theta is equal to mg. You don't know value of t. So from here you are getting value of t, which is equal to mg upon 2 sin theta. This is value of t. This much tension we need. We don't get exact value of t. Exact. It is equation. This is just equation. The rope will be straight when theta will be 0. Yes, if you put theta over here 0, so of course this rope will be in initial was this rope it is straight line. So if we put theta 0, then of course this rope will be straight. But situation is not like this. Situation is not like this. Here by making some angle, it came downward, but little bit, not completely vertically. Okay, not completely vertically. So here you can write t is equal to, when you will put theta as a 0, what will happen? Sin theta will become 0. Sin theta will become 0 to sin 0, which is mg upon 0. It is an infinity number. Infinity number. Tension is infinity. Infinity. The tension required to completely straighten the rope is infinity. The rope will be infinity at angle 0 degree. Clear? The tension required to completely the rope is infinitely. Infinity. The rope will be infinity where theta is 0. Okay. Finally, it is done. After this, we will move towards the next topic, which is addition of two vectors. Addition of two vectors. Let's see in this lecture. Why do we leave this for another lecture? Yeah, why? We have time. Vector to addition. Let me write heading vector of two addition. Addition of two vector. Two vectors.